Gravity is absolute. It demands tribute. It pulls constantly. It pulls everything. Air is thin. Air offers cold resistance. Yet, human beings conquer it. We build machines. We forge wings out of steel. We weave frames out of plastic. We push against the invisible sky. Look at the extremes. Look at the total range. On one side sits total minimalism. 70 pounds of skin and wire. A machine lighter than a human heart's desire. On the other side sits raw mass. 1.4 million pounds. 6 engines burning fire. Crushing the runway under massive rubber tires. How do both fly? How does physics accept both? The rules do not change. Lift must beat weight. Thrust must beat drag. That balance is ruthless. Reduce mass. You drop the need for massive engines. Increase mass. You demand immense structural strength. This script explores those boundaries. The featherweight miracles. The metal behemoths. Welcome to the ultimate spectrum of flight. Every airplane is a battle. A fight between structural integrity and Earth's pull. If a frame is too light, it snaps. If a frame is too heavy, it stays grounded. Engineers walk a razor edge. Consider the lower boundary, human power alone. No fuel, no turbines. Just human muscle pushing against air density. To do that, weight must vanish. Now consider the heavy upper boundary, moving orbital shuttles across continents, moving heavy tanks into war zones. To do that, structural engineering must scale up exponentially. Wing spars thicker than trees, landing gears with dozens of wheels. Both extremes reveal one truth. Aviation is the art of compromise. Every gram counts. Every single pound dictates performance. Let us witness the giants first. Enter the Titan, the Antonov An-225 Mriya. Mriya means dream. Built by the Soviet Union. Designed in the late 1980s. Its singular goal, transport space shuttles. Look at the raw figures. Maximum takeoff weight, 1.4 million pounds. That is 640,000 kilograms. 6 Progress D18T turbofans. Each engine generates over 51,000 pounds of thrust. Together, they churn the sky into thunder. The wingspan stretches 290 feet. The cargo bay spans 142 feet. It swallowed locomotives whole. It carried 200 tons of solid payload. Nothing else came close. 32 wheels touched the ground. Distributed weight saved the runways from collapsing. When it landed, the Earth shook. When it took off, gravity wept. In 2022, tragedy struck. The single-finished Mriya was destroyed in combat. A legend reduced to twisted aluminum. The absolute weight king was gone. Yet its engineering echo endures forever. The heaviest passenger craft still flies. The Airbus A380, the double-decker superjumbo. Maximum takeoff weight, 1.23 million pounds, 560 metric tons. It carries up to 850 passengers. It soars at Mach 0.85. It travels over 9,000 miles without stopping. 4 giant engines suspend a floating hotel. Showers inside the cabin, bars high above the clouds. Yet giant size brings giant challenges. Airports had to widen runways. Terminals had to build 2-tier jet bridges. Twin-engine jets became more efficient. Production stopped in 2021. Yet the A380 commands the commercial skies. Mass creates presence. Mass creates smooth ride dynamics. Heavy aircraft punch through turbulence. They ride the air like battleships on water. They are structural monuments to power. Now step off the cliff. Leave the metal behemoths behind. Strip away every extra pound. Meet the WEB. Built in the late 1940s, designed by engineer William Chana. Empty weight, 210 pounds, 95 kilograms total. You could lift it with 3 men. There was no cockpit interior. There was no soft leather seat. The pilot lay flat on top of the fuselage. Prone position reduced wind drag. It minimized structural volume. A tiny 18-horsepower engine spun out front. It flew at 80 miles per hour. It proved a vital point. Flight does not require colossal power. It requires minimal weight. It requires pure aerodynamic balance. The WEB was absolute minimalism realized. Go even lighter. Remove the internal combustion engine entirely. Rely strictly on human muscle. The Gossamer Condor. Designed by legend Paul MacCready in 1977. Empty weight, 70 pounds. 31 kilograms total. Lighter than a set of luggage. Its wingspan was 96 feet. Framed in aluminum tubes and balsa wood. Wrapped in ultra-thin mylar plastic film. A cyclist sat inside. He pedaled a chain connected to a propeller. He generated barely 1/3 of a horsepower. Yet the craft rose. It skimmed 10 feet above the ground. It won the famous Kremer prize. 11 miles per hour flight speed. A speed you can jog beside. If the wind blew hard, it could brake. Yet it conquered gravity using human legs. It remains a masterwork of structural efficiency. How do we balance safety and lightweight today? Enter modern commercial light aviation. The Cirrus SF-50 Vision Jet. The world's first single-engine personal jet. Maximum takeoff weight, 6,000 pounds. Compare 6,000 pounds to the Mriya's 1.4 million. The Vision Jet is a feather in jet aviation, built out of seamless carbon fiber. One Williams turbofan mounted on the top fuselage. It carries 6 passengers in comfort. It flies over 300 knots. Carbon fiber changed everything. It provides maximum strength with minimal weight. No heavy rivets, no overlapping aluminum sheets. One continuous structural shell. The Vision Jet includes a whole airplane parachute. If the engine fails, the frame floats down. Lightweight permits unique safety systems. Modern materials redefine what is possible. Small jets now do what heavy jets did decades ago. Look at the spectrum side by side. Gossamer Condor, 70 pounds. WEB, 210 pounds. Vision Jet, 6,000 pounds. Airbus A380, 1.2 million pounds. Antonov An-225, 1.4 million pounds. The heaviest is 20,000 times heavier than the lightest. 20,000 times. Yet both obey the exact same physical law. Air pressure under the wing must generate upward lift force. Bernoulli's principle does not care about mass. It only cares about fluid dynamics. Heavy planes compress air with raw speed. Light planes float on air with giant wing surface area. One uses brute force thrust, the other uses extreme wing loading efficiency. Both reach equilibrium in the sky. Where do we go next? Materials science is accelerating. Graphene structures offer immense strength. Electric propulsion changes motor weight. Batteries remain heavy today. Yet solid-state tech will trim mass rapidly. Heavy aviation seeks hydrogen fuel. Hydrogen requires huge fuel tanks. That changes aircraft shape completely. Blended wing body designs will emerge, distributing weight across the entire lifting surface. Light aviation seeks solar autonomy, unmanned craft staying airborne for months, weighing less than a motorcycle, gliding in the stratosphere effortlessly, serving as living atmospheric satellites. The pursuit of extremes never ends. Engineers push mass down to zero. Engineers push payload capacity up to the stars. Flight is our ultimate triumph over gravity. From 70 pounds of plastic and pedal power to 1.4 million pounds of roaring steel, the sky welcomes both. The sky belongs to the bold.